In today's class, we're going to talk about the limit of a function. Now let's start off first by talking about the notation that we would use for limits. It is represented in the box, or in the green box that you see there. Now, when you're looking at it, you're probably thinking about how am I going to read this myth? It's basically read as the limit of f of x as x approaches a is equal to L. Now, L could be a number, it could be infinity, it could be negative infinity. It could also be does not exist. We'll get to that a little bit later on. So this basically just implies as x is getting closer to a number, your function, f of x, is also getting close to something, be it a number, infinity, negative infinity. So let's take a look at an example to help us kind of see what the limit is. So in this example, it says determine the limit of f of x equals to x squared minus 1 as x is approaching 2. So what you're going to notice is I have a table of values there, and we always have our central x value, that we're dealing with, which is x equals to 2. But then you're going to notice that I have some x values that are just smaller than 2, and then some x values that are just bigger than 2. This should bring you back to almost kind of like when you were graphing rational functions, asymptotes, very similar approach right now. So here's what I would like you to do. I'd like you to pause the video, and I want you to fill in the table, and then come back to the video and compare your answers, and then we'll go from there. Hopefully you got the opportunity to fill in the table. You can compare your answers with the answers that I've got here. So if I take a look at my table, I know that when x is equal to 2, my function equals to 3. But I want you to notice on the left-hand side, in other words, as my x values are getting closer to 2 from the left-hand side, the number is also getting very close to 3. Same thing with my right-hand side. My x values are getting closer and closer and closer to 2. My y values are also getting closer and closer and closer to 3, which means that the limit as x approaches 2 for x squared minus 1 is 3. Now that's using a table to help us. But what about on a graph? How can I look at a graph to help me figure out the limit? So in this particular case, we can also confirm this result by looking at the graph of our function, which is x squared minus 1. So if I take a look here, I'm just going to scroll just a little bit more, I notice that I have x squared minus 1, and let's talk about what happens on my graph as I'm slowly approaching the x value of 2. So at x equals to 2, I know that my function is supposed to be at 3. I'm just going to put a circle there so that we can put our eye to it. Okay, now let's take a look. On the left-hand side, as our x values are getting closer to 2, notice how my graph is going towards y equals to 3. Okay, so that there, if I write it, I'm doing the limit as x approaches 2 from the left-hand side of x squared minus 1. That's approaching 3 for me, right? It's going towards y equals to 3. If I take a look now at the right-hand side, if I'm coming in this way, notice how it's going towards that y value of 3 as well. So for this one here, I've got the limit as x approaches 2 from the right-hand side for x squared minus 1. That also equals to 3. So notice how I'm coming in from the left and it equals to 3, and coming in from the right, it also equals to 3 as well. So in this particular case, if you compared what we had from the table and the graph, as we approach 2 for x from the left-hand side and from the right-hand side, we know that our function is approaching 3, the y value of 3. Okay, that's why we labeled them as left side limit and right side limit. The left side limit is always dealing with coming in just smaller than the x value that you want. So this here is your left-hand side limit. And then the other one, the one that I have in orange, that represents your right side limit. Now, this is an important note to keep in mind now. The note that I have there, okay, if L is the limit of a function, f of x, as x approaches the value a, only if the left-hand side limits and the right-hand side limits are equal. In other words, the left-hand side limit and the right-hand side limit must equal to the same thing in order for the limit to exist. Okay, this is the very, very important part. So I would highlight this so that I know that in order for the limit to exist, it only can do that if my left-hand side limit and my right-hand side limit equal to the same thing. When I mean same thing, I mean same number and same sign. That's why you see I call it equivalent statements here, right? I said it in words, but I also put it in notation. So in notation, it says the limit of f of x as x approaches a is equal to L if the limit as x approaches a from the left-hand side for f of x is equal to the limit as x approaches a from the right-hand side for f of x is equal to L. Okay, so your left-hand side limit must equal to your right-hand side limit in order for the limit to exist. Now, if the statement above is not true, then we say that the limit doesn't exist then, or DNE. Now, once we get into limits a little bit more, whether or not it exists at A is a different story. Whether or not the function exists at A. The limit only talks about the behavior as we get closer to A. It doesn't talk about whether or not my function is defined at A. Okay, so I'm going to get to that a little bit later on because a lot of students mix up, does f of a have to exist in order for the limit to exist? Okay, and no, f of a doesn't have to exist in order for the limit to exist. So let's take a look. There's also another note that I'd like to bring to your attention. If your function is not defined on the left-hand side of a, then your function will not have a left-hand limit at a. The same thing can be said if f is not defined to the right of x equals to a, then your function will not have a right-hand limit. So if you think about it, an example like f of x equals to root x, will it have a left-hand limit at x equals to 0? If I draw a quick picture out of the square root of x, the function looks like this. At x equals to 0, if you look at the left-hand side, your function isn't defined for any x values on the left of x equals to 0, which means it cannot have a left-hand limit there then. So for this, there is no left-hand limit at x equals to 0. Alrighty, so it has to be defined along that domain in order for the limit for you to be able to take a look at the left or the right hand limit. So if I use a graph to help me figure out limits, in this example it says for the function f of x in the graph below, determine the limit as x approaches 3 for f of x. So I'm dealing with when x is approaching 3. So if I take a look this way, I'm going to first deal with my red portion. So as my graph goes and my graph as x is approaching 3, my function is approaching a y value of 2. So the limit as x approaches 3 from the left-hand side for my function is equal to 2. Then if I deal with my right-hand side limit, as my function is approaching x equals to 3 from the right-hand side, my function is approaching the y value 2. So the limit as x approaches 3 from the right-hand side from f of x is 2. If you take a look at your right-hand side limit, take a look at your left-hand side limit, are they the same number? In this particular case, it is. So that means that the limit exists. So therefore, the limit as x approaches 3 for f of x is equal to 2. So the limit exists here because coming in from the right-hand side and coming in from the left-hand side, we're going towards that common y value. Let's take a look at example 2. For example 2, it says for the function g of x in the graph below, determine the limit as x approaches 3 for g of x. Now, we're going to first deal with the limit first. So again, I've got my left-hand side limit. So as my graph is going towards x equals to 3, my y value is going towards 2. So the limit as x approaches 3 from the left-hand side for my function g of x is 2. I'm going to do exactly the same thing coming in from the right-hand side now. So coming in from the right-hand side, the limit as x approaches 3 from the right-hand side for g of x, my graph is going towards the y value 2. Now you might look at this now and go, but wait, miss, when x equals to 3, the y value isn't actually 2 because it's an open bubble. It's actually supposed to be 4. So does the limit still exist here? Limits talk about the behavior as we approach x equals to 3. It doesn't actually talk about what's happening at x equals to 3. So in this particular case, the limit exists because they're going to the same number coming in from the left-hand side and coming in from the right-hand side. So therefore, the limit as x approaches 3 for g of x is 2. So when we're dealing with limits, we're always concerned about what's happening near the x value. In this particular case, what's happening near x equals to 3. I don't care about what's happening at x equals to 3. I just care about what's happening when we get near 3. Let's take a look at another example. In this example here, it says for the function h of x in the graph below, determine the limit as x approaches 3 for h of x. So in this particular case, we're going to start off with our left-hand side limit. So for my left-hand side limit, I'm looking at this portion here. And I notice that as my x value approaches 3, my y value is approaching 2. So the limit as x approaches 3 from the left-hand side for h of x is 2. Now, coming in from the right-hand side now, I'm looking at this portion. So the limit as x approaches 3 from the right-hand side for my function h of x, that y value that it's approaching is actually at 4. So now when you compare your left-hand side limit and your right-hand side limit, what do you notice? They're not the same number. In this case, I'm going to write this down. So therefore, since the left-hand side limit doesn't equal to the right-hand side limit, then the limit does not exist here. D, N, E. So in order for the limit to exist, the left-hand side limit and the right-hand side limit must equal to the same number. In this case, it didn't, and that's why it left us with does not exist. Let's take a look at one final example with a graph on the next page. So on this page, it says, consider the following graph of f of x. So we've got this graph here. It's got a lot of different things going on, but we're going to be finding out the limit at the specified x values that it's looking for. So I'm just going to scroll down, and our first question, I'm just going to scroll down just a little bit more. There we go. It says, evaluate the following limits. If the limit does not exist, you must provide a reason. So the first thing that I'm taking a look at, it says the limit as x approaches negative 10 from the right-hand side for f of x. So if I'm taking a look at the right-hand side as x approaches negative 10, I'm dealing with this portion here. So I'm going to underline it so I know what color. So I'm coming in from the right-hand side, which means I'm coming in from here. Okay? So if I'm coming in from here, as I get closer to negative 10 from the right-hand side, what's the y value that my graph is going towards? The y value that it's going towards in that particular case would be negative 2. All right, the second part asks us the limit as x approaches negative 10 from the left-hand side for f of x. So I'm going to use blue to help me out here. So coming in from the left-hand side, I'm dealing with this portion. So as my x value is getting closer to negative 10 from the left-hand side, what's the y value that my graph is getting closer to? That would be 0. So now it's asking, what's the limit as x approaches negative 10 for f of x? You already know the left-hand side limit and you know the right-hand side limit. Compare the numbers. Unfortunately, they're not the same. So in this particular case, the limit does not exist. And the reasoning that we're going to give here is that the left-hand side limit doesn't equal to the right-hand side limit. All right, let's take a look at the next portion. The next portion here says the limit as x approaches 2 from the right-hand side for f of x. So for this one, I'm going to use green. And in my particular case here, this is at, I'm just going to scroll up the graph a little bit. So as x is approaching 2 from the right-hand side, so that's dealing with this portion here, okay? And I know that as my x's are approaching 2 from the right-hand side, my y value that it's approaching is negative 3. Now for my next one, it says the limit as x approaches 2 from the left-hand side for f of x. So I'm going to use gray to help me out for this one. So if I'm coming in from the left-hand side of 2, this is the portion of the graph that I'm looking at now. And my y value, it looks like it's approaching negative 3 as well. So the next portion says the limit as x approaches 2 for f of x. And I'm going to look at my left-hand side limit and my right-hand side limit. And they both equal to the same number, which is negative 3. So the limit as x approaches 2 for f of x is negative 3. Remember, we're not concerned about what's happening at 2. We're only concerned about what's happening when we start approaching x equals to 2. All right, the last portion. So for the last portion, it's asking the limit as x approaches negative 4 from the right-hand side for f of x. So I'm going to scroll back up to the graph. So if I'm taking a look at the right-hand side, sorry, this is the right-hand side. If I take a look at the right-hand side of negative 4, I'm going to use purple to help me out here. This is what's happening. This portion of the graph is what's happening. So as we're approaching x equals to negative 4 from the right-hand side, my graph is going up to infinity. It's actually shooting up. There's an asymptote there. So I'm going to write in positive infinity. Now for the next portion, it asks the limit as x approaches negative 4 from the left-hand side for f of x. So I'm going to use orange to help me out with this one here. So if I take a look at my graph, as x approaches negative 4, from the left-hand side, this is what's happening with my graph. It's going down like that. It's actually going to negative infinity for me. So the limit as x approaches -4 from the left-hand side for f of x is negative infinity. So then the limit as x approaches -4 for f of x, the limit does not exist. Does not exist. They don't go up to the same thing, right? It's not like they're both going up to infinity or they're both going to negative infinity. So the reasoning behind that, the left-hand side limit does not equal to the right-hand side limit. And that's why the limit doesn't exist. So the main takeaway from today's lesson is that in order for the limit for a function to exist, the left-hand side limit must be the same as the right-hand side limit. And limits don't care about what's exactly happening at that particular x value, but rather what's happening as we approach that x value.